This is for Year 12 methods. It's work that I covered today in class while the swimming sports were on. It comes from exercise 2.2 and is solving logarithmic and exponential equations. I'm going to choose 3 examples to do, one out of question 1, one out of question 3 and one out of question 5. The method to follow in a lot of these equations regarding exponentials and logarithms is to set up the equations so that they're the same base in both exponentials or logarithms, and then to equate coefficients or to equate indices or to equate logarithms. So looking at 1k, I've got base 2 and base 4. Straight away I can think I could rearrange this 4 as something at base 2, and that would look like 4 is 2 squared raised to the power of 2, which gives me 2 to the power of 4. And if I expand my left hand side by using the index law of raising to a higher power, we multiply the powers. That's 2 to the x times x minus 4, which is 2 to the x squared minus 4x. Now my left hand side is base 2 to an index. My right hand side is base 2 to an index. Therefore, these indices must be equal by equating indices. So x squared minus 4x equals 4. Now I need to solve for x. X squared minus 4x minus 4 equals 0. Thinking quickly, crisscross, I don't have 4, 1, 2, 2, one of them's negative, but I'm not going to be able to use whole numbers to get negative 4, so I'm going to jump straight away to the quadratic formula. Minus b plus or minus the square root of b squared minus 4ac over 2a. Therefore x is going to equal minus b, which is minus minus 4, plus or minus the square root of b squared, which is 16, minus 4 times 1 times negative 4, all over 2a, which is 2. So I've got 4 plus or minus the square root of 32 all over 2, which is 4 plus or minus 16 times 2, therefore that's 4 root 2 all over 2, which is 2 plus or minus 2 root 2. 2 possible answers for x, 2 plus or minus 2 root 2. There's no problems about placing a negative value here or here, therefore those are my 2 answers for x. Looking at question 3e, it's a logarithm question. Both the same base, so I'd like to get the form of the left and the form of the right the same so that I can equate logarithms. This 2 needs to be moved up using the third law. Log base e of x squared equals log base e of 6 minus x. Since the form is identically the same on both sides, that means that this must equal this. So I have x squared equals 6 minus x, rearranging that x squared plus x minus 6 equals 0. Crisscross 3 and 2, x and x with the negative on the 2, so I have a positive x in the middle. X plus 3, x minus 2 equals 0, therefore x equals negative 3 or 2. The algebra of solving this quadratic gives me 2 answers. However, I need to go back to my question and ask, can 2 fit in there? And that is a yes. I can take log base e of 2, and if 2 goes there, I can take log base e of 6 minus 2, which is 4. Can I substitute negative 3 in here? And the answer is no, because I can't take log base e of negative 3. So while I get 2 answers from the algebra of solving this, in the context of this logarithm, minus 3 is a non-solution, therefore x only equals 2. And the third example comes out of question number 5. And it's an exponential, however, it looks very much like a quadratic. That if I isolate this 3 to the power of x all squared minus 30 3 to the x plus 81 equals 0, it looks decidedly like a quadratic trinomial. And that if I say let a equal 3 to the x, it really becomes a squared minus 30a plus 81 equals 0. And I should be able to factorise that. 81 times 1, 27 times 3, 9 times 9, and the combinations that are going to give me negative 30 will be minus 3 and minus 27, and A. Therefore, A minus 3, A minus 27, therefore A equals 3 or A equals 27. However, I'm not solving for A, I'm solving for x. So if I substitute back for A, I get 3 to the x equals 3 or 3 to the x equals 27. And this one, x must equal 1, and this one, x equals 3. Therefore I get two answers, x equals 1 and x equals 3.